Okay, so sometimes students have difficulties understanding the difference between a cluster sample and a stratified random sample, right? So here's what I have. I have a problem that will help distinguish the difference between the two. And it's the same scenario that we will treat two different ways. Okay, so here's what I have. I have our entire student body in our gymnasium, all right? And they separate themselves with freshmen in one area, then sophomores in another, juniors and seniors are down below. And Chick-fil-A, which is a popular fast food restaurant, is coming to our gym during our pep rally, and they are handing out 200 sandwiches, okay, to the student body, okay? And not every student's gonna get a sandwich, it's kind of like a little reward. Our student body has a total of 3,700 students. Okay? This is a good gym, it's a big gym, okay? And again, not everybody will get one. And what they wanna do is do a random sample, decide who will get these 200 sandwiches, provide them a survey, and then get information and some feedback about the quality of the sandwich, okay? Now, of the 3,700 students, we have different representations of class sizes, okay? So 30% are freshmen, 25% are sophomores, 25% are juniors, and 20% are seniors, okay? And so here's what we're gonna do. We're first gonna do a stratified random sample to determine which students are gonna get a sandwich. And we've already committed to a strata, okay, which will be our classes of students that we have here, okay? So class of students, we have freshmen, we have sophomore, we have juniors, we have seniors, and we're going to represent those off to the side. Okay. Now here's the deal with stratified random sample. I want to make sure that my sample is proportional to my population based off my little subcategories that I have here, which is class. Okay, so what that means is for the freshmen that I have, that's 30%. If my N, which is 200 in my sample, that's what I'm committing to, what I'll have to do is take 0.30 and multiply it by 200. And that will give me 60. So I'll need 60 freshmen. The sophomore class isn't as big, it's 25%. Ooh, too many zeros. And that means I'll have 50 sophomores. And this is 50 juniors, because they have the same percentage. And finally, I only have 20% seniors, and that'll leave me with 40. Okay, now, how am I gonna do this? Okay, how do I pick 60 from all possible freshmen? Well, here's what I have to do. It's the same thing that I've done in the past. And the easiest way for me is to put all freshman names on pieces of paper and put them in a hat. Put all freshman names on paper. Okay. Pieces of paper. Okay. Put them in a hat. Okay. Shake it. Okay. And then we will pull 60 unique names. Okay. When I say unique, what that means is that there is no replacements. Okay, so once you pull a name from a hat, you read the name off, you get a sandwich and a survey. Let me know what you think of the sandwich. That name does not go back into the hat mixed up. Okay, otherwise one person could potentially be a freshman who gets all 60 sandwiches. And how cool would that be if you were that freshman? But we don't want that. Okay, and then you repeat the same thing for your sophomores. Okay, you put all the sophomores, have them put their name on a piece of paper, put it in a hat, shake it up, pull out 50 instead. Okay, those 50 will get a sandwich, okay, and a survey. And then you can do the same thing for juniors, and then follow up with seniors, except that instead of having 50 to pull for seniors, you would only have 40. Okay, so that is a stratified random sample. And again, your sample is proportional to your population. Okay, now here's a cluster. I'm going to write it on this side. Okay, pretend for a moment that all these rows are filled. Okay, and here's what I want to do. I find difficulty, while these are proportional and very balanced based off the class sizes, okay, difficulty finding the 60 names that are somewhere amongst these freshmen, okay? Imagine me picking these 60 names and saying, okay, where is Jack Brown? And you're like, I don't know, maybe he's way up at the top, okay? And where is Jose Garcia? And maybe he's down here. And so on. It's like there's too many names and they could be all over the place. And to hand each kid a sandwich just kind of, as you read those names off, could be a struggle. Okay, and that's just with a freshman. You'd have 50 for the sophomores, 50 for the juniors, and then 40 for the seniors. Okay, and because that's a struggle for your stratified random sample, clusters made to be a little bit easier. Okay, and again, assuming all your rows are filled, here's what we're going to do. I'm going to take the row numbers, okay, 1 through 40. Okay, I'm going to randomly pick choose, and we'll just say 8. Okay, and whatever 8 that we get, we will survey and give a sandwich to all the members of those respective 8 rows. Okay, so let me write this clear. Take the row numbers 1 through 40. Okay, randomly choose 8. Okay, and that could mean, okay, put the numbers 1 through 40 on small pieces of paper. Okay, put in a hat. Okay, shake it. Okay, and then pick, oh darn it. Sorry about that. I'm almost done, so I don't want to start over. Pick 8 pieces of paper. Okay, and with those 8, give all members of that row a sandwich and a survey. Okay, and the survey. Okay. Now, what's the good thing about this? Well, maybe the first row I pick is 5, and the next one I pick is 12, and the next random one I pick is 15, and then 16, and 32, 35, and 39. Okay, and so actually that's just 7. We'll say my last one is 2. Okay, so I have my 8 that were selected, okay? And the nice thing is that it's easy. I can just say, hey, row 2, guess what? You all get a sandwich, okay? And everybody in there gets a sandwich. Same thing with row 5, okay? It's easy to distribute sandwiches and surveys, okay? And again, it's a little bit random, okay? It's not as random as probably I would like, okay? But, you know, everybody in these respective rows does get a sandwich, okay? And then you can collect data from that. Now, what's the disadvantage? Well, it could be a situation like this where when you pick your random 8 rows, it's possible that one group of people get completely left out. And you can see your seniors were excluded, okay? So does that always happen? No, you could pick a different set of 8 and it may be a little bit better balanced. Maybe you get 2 in each of the quadrants within your gym where you have your different categories of people, okay? But there's no guarantee that that will happen, all right? And that's one of the small disadvantages of a cluster is that you may not get a proportional representation of your population, okay? It just depends on how your 8 get chosen, right? So, but that is the difference between a cluster versus a stratified random sample, okay? And again, you know, the intentions of this cluster were good. Once you identified your rows and you realize that, hey, they're partitioned by these different unique subcategories, you know, ideally, and I'll say oftentimes likely, you're going to get a good balanced representation based off class. You're probably going to get close to 2 here, 2 here, 2 here, and 2 for your seniors, okay? 2 for each of the respective classes. But again, sometimes that doesn't happen. And I designed it that it wouldn't, just to show you that, hey, while you did pick your 8, you know, sometimes that doesn't work out to be perfect because, you know, groups like the seniors in this case didn't get representation as they should. So, all right, I hope that helps. I hope that makes sense. If you have any questions, you let me know. Have a great day.